Welcome back to continuing to fix the code that we started to work on a bit earlier. And so in this lecture, we're going to focus on some of the functional and declarative principles that we learned about in the last video. And we're going to focus on three big areas of functional JavaScript, just as we talked about in the last lecture. So that's first, immutability; second, side effects and pure functions; and third, making data transformations using pure functions such as map, filter, and reduce. And let's actually start with immutability, because in JavaScript, there's actually a way to make a data structure, or in other words, to make an array or an object immutable. So let's take a look at that. So let's go back here. And so what we can do is to call the function object.freeze. Then in that function, we pass in the object that we want to make immutable, basically. So by doing this, spending limits is now immutable, which means that we can no longer put any new properties into it. So let me show that to you. But actually this works best in strict mode, which I'm noticing here is actually not activated in this script. But we already know how to do that, right? And so let's see what happens if we try to add a new property to spending limits. Let's say we want to add J, actually, because we have him down here. And so let's say we want to actually allow him now to spend something as well. So let's say 200. Let's give it a save. And if we now check out this object, then you see that it didn't change, right? And so that is object.freeze for you. So whatever we try to add now to this object is not going to work because it has been freezed. So let's do the same with this one here, because in the end, an array is also just an object, right? And so we can also do object.freeze on arrays. Just like this. And now we actually already start running into trouble, because down here, we are trying to push something into this array, which is now no longer possible because, again, we made it immutable by using object.freeze. So right out of the gate, this code here is now no longer working. Now, I actually wanted to show something to you. So let me remove that. But there's probably still going to be an error down here. Well, actually not. And yeah, there's a reason for that, which I'm going to describe now. So you saw that we can not add new elements to this object now, right? So that was the reason for the error that we just saw here. However, object.freeze here basically only freezes the first level of the object. So it's not a so-called deep freeze, because we can still change objects inside of the object. So for example, I can do budget, and then the first element, and then dot value. I can set it to whatever I want. And so if we see now the result here, you see that the value did indeed change. All right. What I cannot do is to add a completely new element. So I cannot say, let's say, object 9 should be Jonas. So that is not going to work. So you see, nothing was added here now. All right. So that's just something to keep in mind when you use object.freeze. Now, there are, again, third-party libraries which implement a deep freeze, but I'm not going to go that way here in this small and simple example. Let's just take out this one here, and then let's keep going. All right. So let's put these back, and that will then bring back our error. And so now we will need to fix this function. So how do we fix this function, and why does it create the error in the first place? So the problem is that right now this function addExpense is trying to mutate this outside object. So in other words, according to what we learned in the last lecture, is that this function right now has a side effect, right? So remember that a side effect basically means that something outside of a function is manipulated, or that the function does something other than simply returning a value, right? And so a function that has or that produces side effects is called an impure function. So this function addExpense right now is an impure function because it does attempt to manipulate and to mutate this object that is located outside of it. So how do we fix that? Well, first of all, we should always pass all the data that the function depends on into the function so that it doesn't have to reach into the outer scope. So that's the first good practice. And then, of course, the function should not change any of these values. So in other words, it should not mutate them. And that's the whole reason why we made this object here immutable, just so we cannot by accident mutate this object, right? So remember that the solution to that is to create a copy and then return that copy of the state, so of the data, right? So I just said a lot of stuff, so let's put all of that into practice here right now. So the first thing that I'm going to do is to pass in a variable called state, and then also the limits here. Okay, so this state here will be the budget object, and then here the limits is of course going to be the spending limits. And so I will pass in all of that here in all of the three function calls. So budget and spending limits. So that of course alone does not fix the error, but we are working in the right direction. Okay, now I said in the last lecture or in one of the previous ones that we should not pass more than 3 arguments into a function. Now in this case here we actually have 5 parameters, but well, sometimes it's not a big deal to break those rules. We could also pass in simply one object of options, basically. But let's keep it simple here. I'm not into the mood of changing all of these inputs here. All right, so this is just fine here. Then next up, here we are clearly manipulating the user variable. So the user argument in this case. And so, as we learned in the last video, we should avoid these data mutations whenever possible. And so let's instead simply create a new variable right here. So let's call this one here clean user, because we are basically cleaning it. This is a common terminology that we use. So this is the whole reason why this Matilda here, even with the capital M, still works. Okay, so I didn't mention that in the previous lecture where we worked about this, but without this piece of code, it wouldn't work, because Matilda here is uppercase, but here in the object, it is lowercase. And so with the uppercase, it would not be found here in the object because this here is lowercase. And so that's of course different. And so here we will always convert everything to lowercase so that it then corresponds to the object keys that we have here. So this one here is from before. Let's actually put it here where it belongs to. So that was the alternative way of getting the limit. Then here we need to use that clean user, and the same here. So we still want this to be called user, so here we need to go back to saying user should be equal to the clean user. Okay, so we did most of the work here, but now actually comes the main part. And again, that is that we want to replace this manipulating of the object by creating a new object based on the state that we receive. All right, so let's get rid of this code here. And instead, what do we want to do? Well, we basically want to return an array like this here, but simply with one more object. So we learned already how to do that actually previously, and it's not very difficult. So let's just say we want to return then an empty array, and then we use the spread operator to put all the elements of the state in there. And so this effectively creates a copy of this state array. Remember how we did that earlier? And so this is exactly the same technique right here. And now all we need to do is to then add a new element right after this one. And that element is going to be this object, which looks exactly like what we had before. All right. And so now we can get rid of this. All right. So right now, calling the addExpense function will actually no longer mutate the budget object, right? And so therefore, if we want to then do something with the new budget, we actually need to store that somewhere. So let's say new budget 1 is equal to this. Then let's quickly log it to the console as well. And so let's see, and here we are. So here is pizza. So that's just the expense that we added here previously. Great. But now what happens if this here turns out to be false? So basically if this code here does not run. Well, let's try that by making this pizza here ridiculously expensive. And so you see that now we actually get undefined. So that's not good, right? And so what do you think we should return in this case? Well, what we have to do is to return the original state. So the original budget that we got in, right? And so in that case, the addExpense function will always return something. So it either returns the original budget or it returns the one with the new expense added to it, right? So let's clean this up here a little bit and simply use the ternary operator here. Because remember, that is a lot more declarative than the more old school if-else statement. So here, let's take away the return and actually put that here in front. So here we will now decide what is going to be returned. So in this case, what we will return is this new state, so this new budget, or otherwise we will just return the original one. Now we got some errors somewhere. It's this one. And here we go. So now we no longer got our error and we are returning the original budget here. And if we put it back to a normal price, then here we go. So here is our object, our updated expense. So our updated budget, but in a functional way. So right now, this function here does no longer produce side effects. It is now officially a pure function. Let's actually write that here, because we're really happy about this now. All right. Now, what about this one here? So the next addExpense call. So do you think we still should pass budget into this one here? Well, not really, right? Because this one will then again act on the original budget. And that doesn't really make a lot of sense, right? Because this previous expense that we just added is not going to be in there, is it? So let me show that to you actually. Put that down here. And create a new one. So let's see. And so here, now we have going to the movies, but indeed we don't have the pizza here before. And that makes sense, right? because we are again using the original budget, which was never mutated by the previous addExpense call, right? And so what we have to do instead is to here pass in the result of the previous operation. So that's new budget 1. So if we see now it will have indeed pizza and going to movies. And then, of course, the same thing here for the final part of the puzzle. So the final expense, the third one. And here then we again use the previous one. So that's new budget 2. But now this one here should be the same as before because, of course, J is not allowed to add anything. Right. So only pizza and going to movies has been added there. Let's make this one here a bit smaller so that it fits in one line. Well, it didn't. All right, so let's just leave it like that. And yeah, so that first part here is now fixed. Now, in the real world, we would use something called composing and a technique called currying to basically create this chain of operations here. So here we need all of these intermediate variables to create a new budget, right? So we call this once, store the result in a new variable, then the next call we use that previous variable, and then again in the next call we use that previous variable again. So this is kind of a chain of addExpenses, and it would be nice to always automatically use the previous result for the next operation. And so again, in a real world big functional application, we would use composing to create one function which will then perform all of these operations at once. But that would really be outside the scope of this course because that is a whole big world on itself. So here we are just trying to implement some of these techniques and some of these concepts just so you see how they work and that they exist and that they are important. And again, this becomes especially important once you start using one of the frameworks out there, just like React or Redux, which rely heavily on concepts such as immutability and pure functions. But anyway, let's now move on here in our code. And now that we already talked so much about side effects and immutability in pure functions, let's turn our attention to data transformations here in this case. Because as you see, here we have this for off loop, which we can easily transform into a functional function, basically. So we have this loop here, which loops over all the entries in the budget, right? So basically, which loops over this array, and in each iteration, the current one is one of these entry objects. And then in this loop, it will update each of the objects to contain the flag attribute, basically, whenever the value is over the limit. So that happened, for example, here. And so we got flag set to limit. Remember that from the previous lecture. But of course, this function is again an impure function because it does manipulate the object itself, right? So in this case, it works with a budget, but the same would be true if we wrote new budget 3 here, which was our latest and updated budget. So this one here actually comes from line 65, so it's this one. So what I would be interested here is this. So let's move that down here. And so here indeed we will now see, so here is flag set to limit. And so we violated the principle of immutability here, right? And therefore, let's transform this function here into a pure function as well. So again, we will want to pass in all the data that the function depends on. And so that's again, well, in this case, it is budgets 3. So new budget 3. And also we actually need the limit from the outside. And actually we skipped this function here, but let me come back to that in a minute. So let's just pass in the spending limits here as well. So let's go back up here. So we passed in the spending limits here into the add expense function, but we actually never used it. And so the reason for that is that get limit here actually uses the spending limits from the outer scope. And that's something that we do not want, right? And therefore, let's add the limits here as another parameter. Limits and user, and then here I can just call it limits like this. And then here I pass the limits in. All right. So it works just like before, but now this function here no longer depends on any external variable. It can do all its work without having to look up in the scope chain. Now, okay, so let's do the same here as well. So here we want to then receive a state. I'm going to call it state to keep it neutral, just like before, and then calling it limits once again. So here again, we want to pass in limits and then the user itself. But now let's then finally actually replace this entire loop and instead loop over the state using one of our data transformation functions. So what do we want to do here? Well, we want to basically keep an array of the same size here in the end, right? So in each of these objects, we basically just want to add a property, but that's all we want to do. We don't want to filter anything, or we don't want to use reduce either, right? So it makes sense to use the map method here. And map, remember, will create a brand new object, so a brand new array. And so that's exactly what we want, right? So that's in the spirit of functional code and of immutability. So not mutating the state, but instead creating a new state based on the original one. And so, in fact, this is then the state that we are going to return from this function. But let's not get ahead of ourselves and instead work here on this. So let's create a function block here and think about what we want to do here. So right now here inside of this callback, each entry is one of these objects, just like this, right? But of course, we still do not want to mutate any of these objects, right? Instead, when this condition here is true, so when the value is less than the limit, then essentially we want to copy the object and add the new property onto that copy, right? So basically just like we did here. So the idea is the same. So here we copied the entire array and then added a new object. But here what we will do is to basically copy the entire entry object and then add the flag property to that. So that sounds a bit complicated, but trust me, it will all make sense. So let's copy this condition here, just like this. And then again, making the code nicely declarative by using the ternary operator. So if this condition is true, so if the value is above the limit, then here we want to return the original object copied. So remember that this creates a copy and add a new property. And so that's flag set to limit. And otherwise, what we will want to do is simply return the original entry. And that's actually it. So let's just check out the result and then I will show it to you again. All right. So here, now of course, we need to again store the results into a variable. Let's call this one final budget because we will not create any new budgets. And I'm then going to log that here. And so let's see if we got the flag here. And indeed, flag is set to limit. So that worked, and you see that we did not actually manipulate any object. All we did here was to create a copy and then add the property onto that copy, right? Now here you might not be used anymore to actually see the return here in the map callback function, but that's just because we have this function block here, right? And so remember that in the map function, whatever is returned from the callback will be the element in the same position of the new array, right? So that's why we need the return here. But of course, we could also completely simplify all of this here if we wanted to make it simpler. So let's take this and actually transform it into an arrow function if you prefer that. So I will then leave these two here. So function and state, then let's say just like this. Then we don't need the return. And here we can get rid of the braces as well and of the return. Let's call this one here 2. And here we don't need that semicolon, I guess. And that's it. Now we're ready to go. And this is basically the same function. Just copy it or actually comment it out. So just in case you prefer this arrow function. So I hope that this made sense. What's really important to note here once more is that we transformed this function here into a pure function which does not mutate anything, because the map method here returns a brand new array. So we give this function an array and it will then create a new one simply by mapping over the original one, which again creates then a brand new one. And in each position of the array, we then either return a copy of the original entry plus the flag property, or simply we return the original entry as it was. And so with this, again, our function is nice and pure and does not create any side effect and does not manipulate anything. Nice. And maybe you're actually noticing that throughout most of the course, we actually kind of followed these principles already, but without calling it functional. And I remember especially the Bankist project. So in a section about arrays. So in there, I told you a lot of times that we should always pass all the data that we need for a certain function to work right into that function. So that, again, it does not depend on any outside data. Because really, you will see in practice that this makes it a lot easier to reason about the function itself. And so if you do that for all of your functions, then in the end, that will make your code a lot easier to understand and a lot more readable. Okay, but with that being said, let's now move on here to our final function. And here again, we have this for loop. And inside of that loop, we are actually constantly manipulating or mutating this output variable here. And that, of course, goes against the spirit of immutability, right? So immutability is, of course, not just for objects and arrays. This also goes for more regular variables. And so in functional code, you will probably never see the let variable. So we're always trying to compute a variable, for example, based on methods like this one here, right? And so here we will actually be able to achieve something similar. So let's think together how we could create a string like this here, simply based on pure and functional functions. So data transformation functions for arrays and also for strings, actually. So let's comment all of this out because, of course, there is going to be a better, more declarative and functional way. So in the code that we had here before, of course, it was very imperative. We said create an empty variable, then we manually said that it should loop over all of the entries in the budget array. And then whenever we had a big expense, which is basically this one here, it should then add the emoji to the output variable here. So to this string, right? But if we really think about this, there is a better way to doing this. So this one here is called output, and I guess we should just actually call it big expenses. So we could have done that before, so giving it a better name. So what we really want to do, and this now I think requires a little bit more thinking on our part, but believe me, it's going to be worth it. So what we really want to do here is not all of this imperative stuff. So what we want to do is actually just filter our array for these big expenses. And then basically for each of the results, all we want to do is to create a nice string containing only the emoji. So let's translate what we just said, and starting with the filter. So entry, and then here the condition is of course going to be the same. So basically an expensive or a big expense. So let's start by logging this here just so we can see what we're doing. Big expenses. And here we say that the state is not defined, and that's simply because I didn't pass it in yet. So just like before, of course, we want to make this function not to depend on any variable from the outside. And so we pass it in here as final budget. So let's see what we have here. And indeed, that is the new iPhone and laptop, which are exactly or big expenses. And so now all we need to do is to get these emojis here out and then create a nice string based on the result. Right? So we have now this array of 2, and so we want to again create an array of 2, but only with these emojis. So let's use a map for that. So again, that is an entry. And here we want the entry dot description, and then just take the last 2 characters. So just like we did here before. All right. And now we can just join that like this as we had before. And there we go. So this here is essentially the functional version of just doing this here. So after this video, you can maybe take a better look and really compare these 2 things that we did here. Let me just show you that we could also have done it in another way. So instead of map and join, we could have done it all in one go using reduce. And so once again, this is a nice use case of showing you a more advanced way of using reduce. So again, the use case of reduce is to basically take all the values in one array and create one value out of them. So reduce them all into just one. And in this case, what we want is our string. And so that's going to be the accumulator. And then as always, we have the current value, then here a callback, and then the initial value, which is just going to be an empty string. So what we want to do here is to basically always return the previous string plus the current string. So that's the previous string and then the current string like this. And of course, we still need to say dot description dot slice like this. So we're almost there already, just missing this separator. And there we go. Now we just have this ugly thing here. Let's see what happens if we remove this here altogether. And yeah, of course, that cannot work. We always need an initial value. And so now we could go ahead and only start reading here, but that's not really necessary. So we can, of course, go back to using just this code, but that's not going to be necessary. Of course, we can just go back and use this code right here and take out this one. So this was just yet another use case of the reduce method that I wanted to show you here, so that we can create even strings using reduce. All right, so I'm leaving this here again for you to compare, give it a save, and I think that with this we are done. So we transformed our initial code, which looked pretty bad, first by applying some general guidelines for modern and clean code, and then now in this video we made our code functional and took out all of the impure functions and side effects and data mutations. So a lot cleaner, a lot nicer, and also, if you ask me, a lot more professional looking code. Now, actually, this function here is not pure. Let me just write that here. So it's an impure function because it creates a side effect by doing this console.log here. Okay? So in fact, all console.logs here are of course impure because they do something. So they create something here in the console in this case. So they create input output. But of course, any program needs to have some side effects, because otherwise, what is the point of the program in the first place? If we didn't have all of these console.logs, how would we even know that the program is running in the first place? Right? It would not be useful at all. And so, as I said, we always need some side effects, but in functional programming, we try to push these side effects as far to the edge, so as far to the end of our program as possible, so without having them all over the place polluting our application. Now, this kind of mini project here is, of course, very far from being complete, and if you wish, you can, of course, develop this a lot further. For example, you can add a function for adding the income, or you can also create functions for calculating the total expenses and incomes, the overall budget, how much the expenses are in percentage of the income, and so on and so forth. But I will leave it like this here, because again, this is enough for us now, and our code looks pretty professional as it is. Just keep in mind again that these are more like guidelines and not really hard rules. So large applications, they are very hard to make 100% functional, and that's absolutely okay. So actually, right in the next project, we will already break many of these rules. And again, that's okay. It's not a big problem. As long as we try to still keep some of these principles in some of the places, we're already making our code a lot better and a lot more professional. Now, okay. And with that being said, you're now ready to go build the biggest and kind of the final project of this course in the next section. And so I really hope to see you there soon.